Today we begin the lesson on metals and metal compounds. This is the first lesson in year 9. It's a continuation of some of the lessons that we have done, or some of the topics that we have done in year 7 and 8. So welcome and let's do this. What we'll be looking at in this topic of metals and metal compounds is that we will first begin by looking at what makes metals, or what is a metal and what is a non-metal. We will also look at reactions of metals and various substances, for example, reaction of metals and acids. We will also look at reaction of metals with other substances like with oxygen, with water and all those. After we finish with that, we will also discuss the reactions of metal compounds and acids. And we will then look at how to write equations, and we will limit this to the reactions of metals and metal compounds with various substances. So welcome, and let's do this together. Now, so far we have about 119 metals and non-metals, or what is called elements, that have been listed in the periodic table. The periodic table is a list of all the known elements which are arranged according to the similarities in their properties. The periodic table is arranged in such a way that you can easily identify an element as a metal or a non-metal. Metals are found on the left and in the center of the periodic table. Examples of common metals include sodium, magnesium, calcium, copper, gold. All of those are metals. Normally they are found on the left and in the center of the periodic table. The non-metals are found on the right of the periodic table. The sample periodic table that we can see, the non-metals are colored green. If you look at the sample periodic table that we have, there is a demarcation or separation of the metals and the non-metals with a group of elements that are colored purple. Now, these are what we call metalloids. Metalloids, as we'll see, they are elements that have unique properties. But that's looking at the periodic table. If you're given a periodic table, you can tell which element is a metal or a non-metal. For example, magnesium, based on its location on the periodic table, that would indicate that it is a metal. Sulfur, on the other hand, is a non-metal. Phosphorus is a non-metal also. Copper is a metal. Iron is a metal. Iodine is a non-metal. But some others, like antimony, would be quite difficult to judge whether they are metals or non-metals. Like we have just said, metals are normally found on the left of the periodic table, and the non-metals are found on the right of the periodic table. Now there is a zigzag line that separates the metals and the non-metals. These zigzag lines runs across from boron to silicon, arsenic, tellurium, all the way down. And this is the line that divides the metals and the non-metals, and it includes elements which we call metalloids. For example, silicon is a metalloid. So what are metalloids? Metalloids are elements that behave like metals and non-metals. That is to say that they are reactions in which they would behave like any typical metal, or they would exhibit properties of a typical metal. There are also instances in which they would behave like a non-metal. They behave like a non-metal. For example, as we'll see later, most of the metals tend to be very good conductors of heat and electricity. Now, some of the metalloids don't do that. So it would then imply that they are probably non-metals. So because they would show, now that they show both properties of metals and non-metals, then we refer to them as metalloids. Metalloids, they have both, they would exhibit both metallic and non-metallic properties. Francium is definitely a metal, just based on its position in the periodic table. Scandium is also a metal. So metals are generally found on the left and in the center of the periodic table. On the other hand, krypton is a non-metal. It is one of the noble gases. It's one of the noble gases, and it is a non-metal. So non-metals are found on the left of, on the right of the periodic table. Cobalt is actually a metal, but a specific group of metals that we call transition metals. So if we reveal, or if we point out, for example, we point out something like iridium. Iridium would actually be a metal. On the other hand, bismuth would most likely be a non-metal, if not a metalloid. If you reveal the elements here, you will definitely know the ones that are metals, non-metals, as well as metalloids. Now that we know the location of metals and the non-metals in the periodic table, then we can go ahead and define the properties that make an element to be classified as a metal. So we look at the properties of the metals. The first property of metals, or majority of the metals, is that they have a shiny appearance. We say that they show a luster. They have a lusteric appearance. Basically, luster is another word for shiny. They reflect light very well, giving them that shiny appearance. Majority of the metals that are used, for example, gold is very shiny and very beautiful. It is actually used because it has a shiny appearance. The other property of metals is that they are very good conductors of both heat and electricity. Conductivity is the ability of an element or a substance to allow something to pass through it very well. So metals tend to be very good conductors of heat. They allow heat to conduct or to pass through them very well. For example, if you heat one edge of a metal, within a given time, the other edge of the metal will also be hot. Why? Heat has passed through the metal very well. On the other hand, they also tend to be very good conductors of electricity. We use copper wires because they are good conductors of electricity. Another property of metals is that majority of the metals make a sound when they are hit. We say they are sonorous. They make a sound when they are hit. Majority of them. There would probably be a few exceptions, but majority of them make a sound when they are hit. One major property of metals is that majority of them, or maybe 99 or 95% of them, tend to be in solid form. They'll be found in solid form at room temperature. Yeah. They are also very strong. In fact, for that reason, they tend to have very high melting points and boiling points. This means that they require very high temperatures or a lot of heat to either melt them or boil them, unlike other substances. So metals in general tend to have high melting points and boiling points. One unique property of metals is that they are malleable. Malleability simply means that they are easily bent or shaped without breaking. For example, aluminium. We actually use aluminium foil because we can easily bend it and without breaking. So they are malleable. They also tend to be ductile. Ductility is the ability to be drawn into wires. They can be made into wires very easily. For example, copper, we make them into copper wires and wire them up and use them for conducting electricity or for electrical wiring. Another unique property of metals is that they tend to have very high densities. Density is mass per unit volume. So they are massive for their volume and very heavy for their size. Very heavy for their size. So these properties of metals may not necessarily apply to each and every metal that is listed in the periodic table. There could be some exceptions to that. For example, like we have discussed all of these properties, there are some that don't display all of these properties. For example, mercury. Mercury is found as a liquid at room temperature. Though we have said that they tend to be solids, or they'll be found as solids in room temperature, mercury on the other hand is a liquid. Others like sodium, as much as we have said that metals tend to be very strong, sodium is very soft. In fact, it is easily cut with a knife. So what we have listed there is the general properties of metals. A few metals may fall from that, in the sense that they could have properties that don't necessarily concur with each one of those metals. But in general, so if you're asked to define what a metal is, you can put a metal as an element based on its property. Now that we know the properties of metals and we know where we can find them in the periodic table, we also need to know what is it that would make an element to be defined or to be called a non-metal. What are the properties of a non-metal? Now, properties of non-metals tend to be the complete opposite of properties of non-metals. Properties of metals. For example, metals are very shiny. On the other hand, non-metals come in all colors and they have no metallic cluster at all. In fact, they tend to be very dull. We have said that metals generally will be found as solids at room temperature. For non-metals, they can be found in each and every single state. They can be gases, they can be solids, or even liquids at room temperature. For example, sulfur and phosphorus, which are non-metals, are solids at room temperature. On the other hand, bromine is a liquid at room temperature, while gases like oxygen, nitrogen, chlorine, fluorine are gases at room temperature. Now, non-metals generally are very poor conductors of both heat and electricity. Probably with the exception of carbon in the form of graphite, all the others are poor conductors of both heat and electricity. They also tend to have a characteristic smell or a pungent smell. For example, bromine has a characteristic vinegar smell. It is colored, it is brown in color and has a characteristic smell. And they are very low in sonority. They do not produce sounds when they are heat. They don't produce sounds when they are heat. In line with the metal property of being malleable and brittle, being malleable and ductile, non-metals tend to be brittle. That is, they shatter and break down when they are heat. They tend to shatter and break down when they are heat. So, properties of non-metals are the complete opposite of properties of metals. So we can fill this table because now, for example, the appearance of metals would tend to be very shiny. Okay, they would have high densities. So we can solve that and look at the properties. If you fill this, you may require a periodic table, probably to look at the position of the elements and therefore conclude as to whether the statement given is true or false. For example, vanadium. Vanadium is atomic number 23. It's actually a metal, so it most likely will be very malleable, and that would actually mean that it is true. Iron would also have a high density. Looking at the properties of metals, each and every metal and its usage depends on its property. Not all metals can do the same job. Rarely do we get bridges made of magnesium. They would tend to be made of iron because it is very strong. Okay. On the other hand, if you wanted to wrap your food, you would not use magnesium. You would preferably use aluminium. Why? It's very malleable, and also it is being a good conductor of heat, so it can actually, and having a shiny appearance, it will actually reflect the heat inside the food and keep your food very warm. So each and every metal in its usage, it makes or it is used based on its property. We make jewelry from gold. Why? It is shiny, it is malleable, and it is resistant to corrosion. On the other hand, we can use iron to make bridges. One, it is very strong, it is malleable, and also tends to be very cheap. Now we cannot manage to have a golden bridge to be